Hello friends, I am Ranjit Dhunde. Welcome back to the lecture series on the topic Laplace transform. In this lecture, we will discuss inverse Laplace transform of derivatives and integrals. For this, we recall multiplication by t property and division by t property. If Laplace transform of f of t is equal to f bar s, then Laplace transform of t times f of t is equal to minus d by ds f bar s. This is the multiplication by t property, and Laplace transform of f of t by t is equal to integration s to infinity f bar s ds. This is the division by t property. Now inverse Laplace transform of derivatives and integrals. If inverse of f bar s is equal to f of t, then inverse of this d by ds f bar s means inverse of derivative of f bar s is equal to by using the definition of inverse Laplace transform, Laplace transform of t times f of t is equal to minus d by ds f bar s. Then inverse of d by ds f bar s is equal to minus t times f of t. So this is the inverse of derivative of f bar s. And inverse of this integration, inverse of integration s to infinity f bar s ds is equal to this f of t by t. So this is the inverse of the integral. Now let us solve some problems by using inverse Laplace transform of derivatives. Now example 1, find inverse of log of s plus a upon s plus b. Now this given function is denoted by f bar s. Let this f bar s is equal to log of s plus a upon s plus b. Now log of s plus a upon s plus b is equal to log of s plus a minus log of s plus b. Now differentiating this with respect to s, differentiating with respect to s, the derivative of f bar s d by ds f bar s is equal to derivative of this log of s plus a, answer is 1 upon s plus a, minus derivative of log of s plus b, the answer is 1 upon s plus b. Now applying inverse Laplace transform to both sides, the inverse of d by ds f bar s is equal to inverse of 1 upon s plus a minus 1 upon s plus b. Now inverse of d by ds f bar s, the inverse Laplace transform of derivative, answer is minus t f of t. This is equal to inverse of 1 upon s plus a, answer is e to the power minus at, minus inverse of 1 upon s plus b, answer is e to the power minus bt. Now multiplying this whole equation by minus 1 and dividing by t, so therefore f of t is equal to e to the power minus bt minus e to the power minus at upon t. Now this f of t be the L inverse of f bar s, and therefore L inverse of f bar s is equal to this answer, and f bar s be the log of s plus a upon s plus b. So therefore L inverse of log of s plus a upon s plus b is equal to e to the power minus bt minus e to the power minus at upon t. Now second example, determine f of t if f bar s is equal to half times log a square plus b square upon a square plus a square. Now here f bar s is equal to half log s square plus b square upon s square plus a square. The answer is log of s square plus b square minus log of s square plus a square. Now differentiating this with respect to s. Differentiating with respect to s. Now derivative of f bar s d by ds f bar s is equal to half. Now derivative of log of s square plus b square. So log of s square plus b square 1 upon s square plus b square into derivative of s square plus b square. Answer is 2 times s minus derivative of log of s square plus a square. Answer is 1 upon s square plus a square into derivative of s square plus a square. Answer is 2 times s. Now multiplying this bracket by 1 by 2. So therefore this d by ds f bar s is equal to this half into 2 means this 2 get cancelled. Similarly half into 2 again this 2 is cancelled. The answer is s upon s square plus b square minus s upon s square plus a square. Now by applying L inverse to both sides, the L inverse of d by ds f bar s is equal to L inverse of s upon s square plus b square minus s upon s square plus a square. Now inverse of d by ds f bar s, answer is minus t f of t is equal to inverse of s upon s square plus b square. The s upon s square plus b square be the Laplace transform of cos bt. Therefore inverse of s upon s square plus b square, answer is cos bt minus inverse of s upon s square plus a square, answer is cos at. Now multiplying this equation by minus 1 and dividing by t, we get f of t is equal to this cos at minus cos bt upon t. So this is the required inverse and this is the required function f of t. Now example 3, find inverse Laplace transform of log of 1 plus 1 by s square and hence show that inverse of 1 by s log of 1 plus 1 by s square is equal to integration 0 to t 2 by x times 1 minus cos x dx. Now first we find inverse of log of 1 plus 1 by s square. Now this given function log of 1 plus 1 by s square is denoted by f bar s. The let f bar s is equal to log of 1 plus 1 by s square. Now cross multiplication, so this f bar s is equal to log of s square plus 1 upon s square. Now again log of s square plus 1 upon s square, answer is log of s square plus 1 minus log of s square means 2 times log s. Now differentiating this with respect to s, differentiating with respect to s, the derivative of f bar s d by ds f bar s is equal to derivative of log of s square plus 1. The derivative of log of s square plus 1, answer is 1 upon s square plus 1 into derivative of s square plus 1, answer is 2 times s minus 2 again derivative of log s, answer is 1 by s. Now by using L inverse to both sides, the L inverse of d by ds f bar s is equal to, this 2 is common, L inverse of s upon s square plus 1 minus 1 upon s. Now inverse of d by ds f bar s means minus t f of t is equal to 2. L inverse of s upon s square plus 1. The inverse of s upon s square plus 1, answer is cos t, because Laplace transform of cos t either s upon s square plus 1, 2 times cos t minus inverse of 1 by s. The inverse of 1 by s, answer is 1. Now multiplying this whole equation by minus 1 and dividing by t, the f of t is equal to 2 times 1 minus cos t upon t. So this is the f of t, means required function. Now we prove second part. L inverse of 1 by s log of 1 plus 1 by s square is equal to integration 0 to t 2 by x times 1 minus cos x dx. Now for this we recall Laplace transform of integral property. We have Laplace transform of integration 0 to t fx dx is equal to f bar s upon s. Now by using the definition of inverse Laplace transform, inverse of f bar s upon s, L inverse of f bar s upon s is equal to integration 0 to t fx dx. In this problem, this f bar s be the log of 1 plus 1 by s square is equal to integration 0 to t. Now this fx, the fx means replace t by x in f of t. So we get 2 upon x 1 minus cos x dx. Hence proved. Hope all of you have understood this topic. In the upcoming lecture, we will find inverse Laplace transform by using convolution theorem and partial fraction method. Please subscribe the channel and let me know your comment and feedback. Thank you. Have a nice day.